if you make security tooling easy and accessible to adopt, developers will adopt it. So developers do want to do the right thing, but they don't want it to be a protracted, long, difficult, cumbersome experience because they want to write code. They want to get hacking. They want to build things.
This is DevOps Paradox, episode number 277, Making Security Tooling Easy for Developers. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farsick. Victor, how much do we really care about security in our software?
We care only when it's discovered that we are not secure, when somebody steals something.
Isn't that telling people that we're just being lazy when it comes to security?
Very often lazy. Many other times misunderstood how to deal with it, right? Because we very often delegate security-related tasks to people who have nothing to do with it, kind of no experience, nothing, right? What does a Node.js developer know about libmx security threat that happens to exist somewhere but is not directly or hardly even indirectly related with the code that person is writing? Close to nothing, right?
Exactly. And on today's show, we have Luke Hinds on. Luke, how are you doing?
I'm doing very well. Great to be with you both. Good to be here.
So Luke has a very long and storied history when it comes to security, and specifically open source security. Now, Luke, what is the one project that you sort of tie your name to right now?
I guess one that's very popular and I'm well known for is SigStore. So that's one of the projects I started back in 21. But several open source projects I've been involved in over the years. But that's one that's certainly got a lot of traction and engagement and a lot of people very interested in collaborating and integrating with the project. So it's had some remarkable success, really success that I never really expected from the beginning.
Now, if people have been living under a rock, what does SigStore do?
Sure. So SigStore is essentially around providing cryptographic integrity of an artifact. Now, traditionally, as Victor alluded to earlier, security has always been a somewhat cumbersome experience for developers. It's something that they feel can restrict them and slow them down. And we had noticed from looking at the software supply chain and open source security and package managers, we'd noted for a while that there was never any decent traction around introduction of cryptographic signatures. Now, cryptographic signatures will give you the ability to understand that an artifact that you're receiving, whether that be a tarball or a binary or a container image, originates from the source that claims to have generated or developed or had some level of engagement with that artifact. The adoption of this technology had always been very, very spotty and generally quite poor over the years. And a lot of this was the tooling. So back then, the main go-to tool was GPG or PGP. And I wouldn't be disrespectful to it. It's an incredibly brilliant piece of work, but we're talking about 30 years ago. GPG was originally developed, and it's proved to be problematic over the years. It has its problems. This was the only tool that was around that package managers and software producers could use. And as I said, because the UX of the tool was a challenge, the adoption was always very, very low, okay, which meant that there was never sign-in by default. You could never get this integrity by default. It was always usually a small population of a developer community that might implement this. And typically you're more kind of geek hacker types. Okay. A lot of this was very difficult to fix an identity to a GPG key pair. It was also a challenge to actually implement these tools into a modern development environment. What I mean by a modern development environment, predominantly a DevOps CI-driven process of development, okay, where there's many machines that are ephemeral, they're created quickly, they're spawned, they do a job, they're destroyed. It's a very sort of ephemeral, short-lived environment. And so the idea was that could we fix this? Because you get a lot of good things with cryptographic signing of packages and artifacts and so forth. One, you can guarantee that somebody's not tampered with it in transit. So you could have a container image that has a particular namespace, and you believe you're getting that legitimate container image when you're deploying it on your Kubernetes cluster or on your local machine. But there's no guarantees to know that somebody else has possibly produced it or somebody's tampered with it when it was built during the time that the container was actually built and then pushed to a registry. And the same for different package managers as well, NPM and PyPy, the same sort of thing. Does it actually come from the source repository that it claims to have come from? So Sigstore's call to action was to make that easy. Generally, if you make security tooling easy and accessible to adopt, developers will adopt it. So developers do want to do the right thing, but they don't want it to be a protracted, long, difficult, cumbersome experience because they want to write code. They want to get hacking. They want to build things. So that was Sigstore's North Star, was to make it easy for developers to produce cryptographic provenance of what they produce from their code. And then in turn, users can get those guarantees. So that was our North Star. And we did pretty well in achieving that.
Once you got Sigstore up and running, now Sigstore is made up of multiple tools. Victor's talked about them. I've talked about them. Cosign to me is one of the biggest ones. How did you decide that, okay, we've got this thing, it's open source, where should it land?
Originally, the project started off with this element called Recore. And Recore is what we call a transparency login. And you could kind of think of this as it's somewhat blockchain-esque. It's a store which is difficult to tamper with. So it's a good source of truth, okay? And so we first of all built this for storing of the cryptographic signatures and the digests. From there, we started to experiment more around the generation of the keys and making that easier. Okay, so that's where this second project came online called Fulcio. And around this time, I'd been working on Recore for a while, and I started to introduce the project to other people to see what other people thought of it. And from there, it was a very typical open source story. Okay, so I built this thing, I share it with someone else. Is this useful to you? What do you think? And then hopefully they will say, yeah, I actually want to do something like that. Can I collaborate? And then you get that magic thing of 1 becomes 2, 2 becomes 3. So I originally spoke to a chap called Dan Lawrence, you may know of. He was at Google at the time. We had both been starting to work on different projects, like it was a project. He was in Tecton at the time. It was a project Chains that was started, and there was discussions around forming the OpenSSF as well. So I shared this with Dan, and he was keen. He jumped in, and Dan started working on Cosign, one of the first tools, the CLI tools on top of Sigstore. And then the other key person to Sigstore, Bob Calloway, came in as well. And Bob Calloway's at Google now. He runs the Google open source security team. Those folks produce OSV Dev and various projects like that. And of course, Dan has gone on to start ChainGuard, who now do the CVE0 images based on Wolfie and so forth. So those guys came in and we started to build and we started to get some traction then. And I soon realized that for this to be successful, for this to get wide adoption, to get the package managers, which was one of the key things that we wanted to do, was to get package managers to produce secure software. We realized that we had to be a public good entity. Okay, we couldn't be fixed to any particular corporate. And the model that I wanted to copy was Let's Encrypt. Okay, so Let's Encrypt, it's a service, effectively, that's free to use. And the idea is with Let's Encrypt, you don't pay more and you get more certificates or you get a higher tier of rate. It's available for everybody. So with Let's Encrypt, it could be used by a large corporate company that are producing lots of certificates, or you could be a 10-year-old in your mother's basement and you want to set up a blog and you need a certificate. So we modeled pretty much after that. So I realized I need to get this into a neutral foundation of some sort. So I spoke to the Linux Foundation. They were very interested, and Sigstore was then, I managed to get the CTO of Red Hat to sign off, and we donated the project to the Linux Foundation. So yeah, the idea was lots of companies were starting to come in. We had Google, Red Hat, VMware, HPE, various other companies were coming in, and I knew that for it to be a very good, vibrant, multi-vendor ecosystem, it needed to be into a foundation. So we went into the Linux Foundation. And then we later went into the OpenSSF a bit later when that was formed. And that was a good move. I've always found projects are more successful where they have a neutral governance, if you see what I mean. There's a good system in place to support a diverse community.
Once the OpenSSF was created, everything landed inside of OpenSSF, which is part of Linux Foundation. You start following the family tree on this, it gets very confusing sometimes, but at least this point, it's simple. So all the tools are there. You've got all these big companies. You've got the Red Hats. You've got the Googles. You've got the Ciscos. You've got VMwares. Everybody seems to be happy. Then what happens?
I think some of the success of the project, so we got the fundamentals in place. The foundation was established. And I think some of the key benchmarks for us, and I'm aware when I say this, I don't want to miss anybody out, but a key one was GitHub. Got quite interested. Cosign was being used predominantly in GitHub Actions to sign containers. So there was a Cosign action, a very simple GitHub action that was built to sign your container images with Sigstore and Cosign. This started to get really good traction, and some folks at GitHub noticed this and obviously saw a need that they had and saw a good community there, wanted to take a community-centric approach. So GitHub started to get involved as well, which was great to see those folk come in because they are very central to things with so many code repositories being hosted in GitHub. And from there, like I said, we had Cosign. I'd been experimenting writing a Ruby Gems library that we were hoping for those folks to adopt. A Python library started with the plan of that going into Python. We started a Rust library. So we started to build out these different libraries. And one of them that was built out was a JavaScript-based Sigstore library or quasi-library CLI. And this was predominantly driven by the folks at GitHub. They got some really cool engineers to come in and to build this. And the interesting thing there is that this then went on to provide the provenance within NPM. So now if you go onto the NPM registry and you search for various packages, you'll see there's a Sigstore provenance section on the website, or they have an API that you can call. So what you can do then is you can get guarantees that the package was actually built by GitHub Actions within a specific repository. And again, this gives you these guarantees around knowing where the package came from, because quite often what can happen is there's various attacks that will make use of this lack of provenance. So provenance is essentially the guarantee that an artifact comes from a certain code base, a certain code repository. When you provide this provenance, you can sense other particular attacks. One of them could be typo squatting. So you might have pandas with an S and then pandas with a Z. The typo squatting package will do something called starjacking, which is where they claim they come from a different repository, usually a very popular one. And what will happen is the package managers will take this metadata around popularity, not question its source, display it as a metric. Developers see it, they think it's a popular package, they assume it's the package that they want to use, but it's not. It can be something that's backdoored or malicious in some way. So providing this Sigstore provenance with NPM, you can start to get guarantees that when you run NPM and you're getting a package, it comes from where you believe it to be coming from. And so since then, really, we've started to build out these libraries. So we're becoming a bit more of a library-centric project at the moment. We have these Python libraries, Java libraries, RubyScript libraries. There's a Rust library. And we want to help package managers adopt the technology. I think the other key part of SigStore is we run something called a public goods service. Okay, so this is similar to Let's Encrypt. We have these servers are online that allow you to get these software signing certificates and make these entries into this sort of blockchain-esque ledger called Rekor that we have. But actually, it's actually a transparency log. It's not a blockchain. I don't want to bring the blockchain folks into this and all the drama that can usually play out between which is best, a transparency log and a blockchain. We have these services that need to run. So these are actually run by the community. So we have community SREs who are on rota, on call, and they monitor this system for any outages, any spikes in traffic, and then keep the service running. Because obviously this is somewhat of a critical service. People rely on this to know that their software is coming from the place that it claims to have come from, that it's not been tampered with. So we're starting to become a bit of a critical infrastructure, essentially. People are starting to rely on us for security. So it's important that we have a good, robust, stable, highly available service for people to use. So it's been really exciting to see all this happen and being built and put into place. And in a lot of the ways, I'm just the idiot that started this. Lots of other smart people are coming along and taking it in the direction that it has, So, if I hadn't have got that initial traction where other people were interested in being part of the project, wouldn't have likely got to where it has today. I have this saying, it takes a village to raise a child, to solve a problem. And that's very much been the case with SigStore. It's very much a community-driven effort.
I'm interested in the part that you said that you have a number of volunteers that are monitoring the system, basically acting as SREs, right? How easy or hard it is to create something like on-call service based on volunteers alone, right? Well, most of the other examples that I know personally, right, they're people who are paid to be at certain time, at certain place, and do certain things, right? Well, you're accomplishing something very similar with volunteers, if I understood correctly?
That's correct, yes, that's correct, yeah. So anybody is welcome to become an SRE in SigStore, anybody from the community. Generally, though, the people there are part of companies that are using SigStore, so they have an interest in that. So, of course, GitHub, they're very reliant upon SigStore being a highly available service. Google, they use SigStore internally. My company, Stacklok, we use SigStore. We rely upon the public instance. So most of the people there do have kind of a daytime employees, so to say. They're sponsored to be there. So without that, it could be quite difficult. I do know that is a difficulty in some open source communities. Some of the package managers, for example, where they have to rely on people. So normally there's a corporate sponsor by proxy of the person being there quite often.
What happens when, not if, the Rekor servers go down, where you have a scenario? And the reason why I'm asking this is recently I was renewing some of my certificates through Let's Encrypt, and Let's Encrypt was going through maintenance. And during that window of time of maintenance, which took about an hour and a half to 2 hours, I couldn't get a certificate for a server that I was just bringing online, which threw me back a couple hours. What happens when Rekor goes down?
These things do happen, so you prepare for them to happen. Okay, so we have lots of playbooks that we've devised to allow us to kick into action should there be any sort of outage. We've built Rekor and SigStore, the public instance, to run on, obviously this runs on Kubernetes. So this is very coders config driven. Okay, so we can create new workloads very, very quickly. If there's an outage of a particular system, then we can migrate that to different compute. We can, there's many different ways that we can approach that outage. We also have a lot of monitoring and probes that measure the health metrics of the system. So generally, when an outage does occur, to a degree, it's sort of, how long is a piece of string? Each outage can be unique. There could be a bug that's been introduced by a developer which has caused an outage. And as an outage occurs, an SRE will immediately be paged. Okay, they will acknowledge the outage. They'll start to look at that. Generally, there's others that will then jump in and help them. Sometimes it can be, it could be a problem with the infrastructure. Other times it could be a bug that's introduced. So generally, it's best efforts. We do have an SLO, a service level objective that we have, which I can't recall to mind, but it's up in the 99% range. We don't provide an SLA because it's a commercial service, but we do have an SLO. And we've actually done very, very well around our overall outages within a certain period of time. It's proved to be very successful, our uptime. I don't have the actual figures to hand. But yeah, to go back to your question, generally, there's no outage that's the same. The root cause needs to be established. Most of the SREs are people that are maintainers of the project, so they know the code very well. And it's generally find out the issue, resolve the issue as quickly as we can. We also do a post-mortem. So we look at what happened, what can we learn from this, how do we not repeat certain mistakes. So we always, we have a very blameless culture. Things do happen. Developers write bugs. Services occasionally suffer outages. So we seek to learn from that with a post-mortem and a sort of a blameless introspection as to what went wrong. I think the other key thing to say is there's two facets to Sigstore. One is the sign-in, so the sign-in of a container. The other is the verification, which is where you verify that signature is legitimate so that you can clarify the provenance that's associated with that signature. Within Sigstore, we have this ability to have offline verification. So you can, in fact, verify without requiring the recall log to be there, the actual service to be there. So this is used quite a lot by folks that run Sigstore within a air-gapped environment. Okay, some people have very super strict environments where they're not allowed to call out to an external system. So they use these things that we called offline bundles to effectively perform an offline verification.
What's really going on in that offline bundle? Because to me, it would seem like that has some sort of identifiers that would need to be kept up to date over time. Am I missing that?
The offline bundle is effectively, it's an attestation which is signed with our root certificate. So we have a root CA in Sigstore. That will give you verification that there's a certificate chain to the Sigstore root so that somebody signed this particular artifact or container via Sigstore. The log is actually required so that it's publicly transparent, so everybody can see that sign-in event has occurred. So the bundle is essentially it's a set of certificates, it's a set of claims that have a root sign-in to Sigstore. So you can verify this has been signed by Sigstore. If you really wanted to go belt and braces paranoid, you could also check that it's in the transparency log, because if it's in the transparency log, it's publicly exposable to everybody as well. So that's a principle of ensuring that we behave, if you see what I mean. We're not concealing things. We're not signing things, but not letting anybody know about the fact that we've signed things. So that's a good way of keeping us publicly accountable. But it's essentially it's a set of certificates that you can clarify. A sign-in is fixed to a root. Same thing happens in your browser. You go to a website, you have a CA store within your browser, or if you've got a Linux machine, I think it's etc/SSL certificates, you're able to sort of validate against the root. So it's a similar principle.
What happens when that root CA expires?
What we actually do is we have a community root. So what do I mean by that? So we have a system where we have a group of people that sign together to create a new root. And this happens, I think it's every 12 months. And we do this publicly. So when we did the first one, this was actually streamed, okay, when we created this root signing certificate. And we also use a project called the Update Framework, which allows multiple parties to sign together to create a trust root, okay. It's a bit like, you remember Ghostbusters where they'd cross streams? That's the kind of principle. And so we actually streamed this. And what we did was to validate that it was happening in real time, people asked us questions like, what's the weather like in Berlin today? What's the temperature? What's the price of Bitcoin today? What's the headline on the front of the New York Times for this date? So people could validate that this was a real event happening at that particular time. And then people came in and they verified our signatures. So we set up our trust route like this. So it's effectively a community trust route that's made in the open. When we need to renew that, we can renew that by coming together and signing a new route. So that's effectively how that works. And that's actually, there's a GitHub repository, and I can't recall the name of it, but it is in Sigstore, where you can see our route signing. I think it's called route signing, in fact. So you can actually see the cryptographic record of where we create these open community routes. And it's very different to a commercial CA. They do this behind closed doors. So you don't really know who's there when that certificate is created. I'm not suggesting there's anything nefarious or dodgy happening, but our CA is created in the open. So anybody can go in and verify.
And it does appear that the repos are either root signing and root signing staging, it looks like. I haven't found
Yes, there you go.
Yet.
Yeah. So we have a staging environment as well.
I want to go back to the typo squatting, because this is always interesting to me and also terrifying at the same time. General typo squatting using pandas S, pandas Z or Z, makes sense, right? That's just typical typo squatting. But what happens, like we had this year with XZ? Basically, XZ was a long con. Somebody came into that and caused problems within something that's up to that point been highly trusted. Is there any way that we'll be able to ever deal with that? Because if they were using, I don't know if they were using Sigstore or not, but if they were using Sigstore, it basically would have just been another day in paradise.
Yes, yeah. So Sigstore wouldn't help there. So to clarify, Sigstore isn't a panacea. It doesn't solve everything. And that's a really good example there, because that was a long, protracted effort by, I can't remember the individual's name, but, they obviously spent a lot of time curating a presence in open source. It's a particularly difficult attack to negate, okay? Because a lot of what we do in the community is based on trust, okay? And there's two aspects of trust, okay? You've got the sort of machine-like trust, which we're speaking about with Sigstore, zeros and ones, cryptography, mathematics, proofs, verification, all of these sorts of things. There's another level of trust which machines aren't very good at gauging, which is interpersonal human trust. And we have these very complex trust systems between us. Okay, so a good example could be, hey, my pipes might blow up and I need a plumber. Okay, and I moved to the area and I don't know anybody. I don't want somebody to charge me a stupid amount of money. So I use my trust network. So I speak to Victor. Victor, hey, do you know any plumbers? And you can say, yeah, my brother-in-law. I'll send him over. His name's Mario, no pun intended. He'll get you, he'll see you good. So I've relied upon my trust network then. And as humans, we use that a lot. And machines are not so good at being astute enough to understand those trust relationships that we have as humans. One of the interesting things that we're doing in Stacklok, and it is quite early days, is we have this project called Trusty, where we're using data science to try to extract meaningful signals from open source. Okay, so one of them that we use is Sigstore. So this is the tie into Sigstore. We want to understand the signal of a community, and I'll go into what signal actually means. What does that constitute? We need to rely on it being we can find truth in data. We have that Sigstore verification so that we know that a artifact comes from the repository that it claims to come from. So one of the things that we're doing in this project Trusty is we've built a graph of open source contributors. Effectively, what happens is there is a sort of proof of diligence within open source. When somebody contributes to a project, there is a certain amount of work that's required in that. You need to make a bug fix or develop a feature which is useful to that project. It needs to pass CI. It needs to have good unit tests. Okay, so you put time and effort into making that contribution, and then that project accepts that contribution. okay, which means that they deem your work to be useful. So you have a sort of a level of human trust association there, okay. There might also be a case of the people know you. They've met you at a KubeCon, or they've spoken to you on Slack, okay. And so we've looked at this quantifiable, measurable proof of diligence, that we call it, within open source, okay. So if I let's say Kelsey Hightower, and I contribute to Kubernetes, okay, I have built up a kind of a reputation with that project. If I then contribute to a smaller, lesser known project, it indicates that project is likely of a certain quality, and there's a certain community around that. So we've been building this technology, and one of the things we claim that we could have solved the XY, but we would have seen elements of it because a lot of sock puppet accounts were also used. So you had the main attacker, who was a human who curated that presence over time, but they also leveraged on these sock puppet accounts to elevate and to sort of to help get in their code accepted into various other communities and so forth. So that's one of the things that we're looking at. There are other things as well around runtime protection, but I'm really not too sure of what else could have really helped there. I mean, I think that the key thing is that what really helped to negate this attack was that it's open source. Do you see what I mean? Somebody, I think it was an engineer at Facebook, they were running Valgrind, and they noticed some very, very hungry resource usage and started to look into the code, and they found the bug. And I think that's the key thing here, is open source, because it's open, it's transparent, anybody can look at that. We were able to find that attack before it really got out there, because the attack was actually stopped before that code became part of long-term LTV distribution releases and so forth.
You were talking about using data science. Please don't tell me you're using AI.
We are actually not. No. So we're doing a lot with data science, but we're not using generative AI. We do use it occasionally for recommendations, but it's not part of our main data science function. This is the Project Trusty that I was talking about. Every time somebody publishes a package, whether that be on PyPy or Crates or Maven or Go or NPM, we ingest that package. Okay, so we ingest the metadata that's associated with that package. Okay, and that's like things such as who contributes. Does it have a source of origin claim, so that we know that we're not being duped and fed false data? So we pull in the metadata associated with this project. And then we run that through various very traditional data science models, such as principal component analysis, something that's been around for years, and probabilistic theory. And we use things like algorithms such as Levenstein distance. Okay, so that's used for calculating a similarity between a name. So this is the whole pandas, Z and S. Okay, so our algorithm would pick up that there is a likely typo squatting attack that's happening here. So we use data science to look for these certain signals that are indicative of something being not quite right. So if you think about it, let's use pandas again. If you have github.com/pandas, I don't know the name of the org, but you have the repository where the pandas code is, okay? And so what we do is we make sure that the project that's claiming to be pandas does actually come from that code base. We can then also look at other things such as the frequency of commits, tags and releases, to look at those match up, because that again is something that's very difficult to game, because you'd effectively have to go back in time and make releases at a specific time at the same time that you publish a package. So we start to look at all these signals, and we use data science to give us a level of confidence around, does a package need more scrutiny? When our data science folks started to originally work on this, we did a lot of testing, and we found that this was very, very good at discovering malicious packages. Okay, we noticed that malicious packages had certain sort of behavior heuristics. A typical one would be it's a new contributor that hasn't really been seen before, and they suddenly create 50 different packages that are using auto-generated names. That's typically how they go about doing things. They'll go for a large blast radius in the hope that some poor sucker will run npm install and pull in that malicious package. So we look for these signals essentially to understand that a package is possibly malicious. And we managed to pull up a lot of packages. We did some work recently with a community called Tea, as in tea like I would drink all the time, a cup of tea, TEA. And they had this Tea protocol. And the Tea protocol seeks to award people for open source contributions. They effectively measure the amount of contributions you've made and to which projects, and then they will, they'll recognize your efforts and they'll pay you through this Tea protocol. It's some sort of crypto Ethereum type thing that I don't know too much about. And we noticed that a lot of people were creating packages. There was these new authors coming along in npm, and they would suddenly create 600 packages within 12 hours. And our system was kind of, our CPU usage spiked up significantly. We were like, so what's happening here? So we looked into this, and we noticed all of these projects had a file in them called t.yaml. Okay. So we looked inside this t.yaml and we saw these codes. And they look like wallets, like public keys. Okay. So we then found effectively that they were using this Tea protocol. So what they were doing was creating these projects and then having them dependent on other projects that they'd created, and creating this huge network of projects, all making it look like the contributor was very prolific and busy, with the idea that they would game the system and then get lots of rewards. So we worked with the Tea community and npm to pull down some of that attack. Some of it's still happening to this day. We're still trying to work out how to get on top of this. But yeah, we spoke to the folks at Tea to highlight the attack to them. We let them know about the malicious authors that were looking to spoof the system and reported these to npm. So that's basically what we do. This is a project. It's very new. It's only being built we've been at Stacklok, we've been going for about a year. And we built this over the past 6 months or so, but it's a heuristic system to signal that packages are of a particular risk. They have a certain risk profile. And we have another project as well, Minder, which is an open source software security platform. It's an Apache 2 platform. Again, we run a public good instance of this, although it's not community run. It's folks in Stacklok, but these are all people that are part of the community. And Minder is a system to provide software supply chain security to communities, developers, teams. Okay, so we do various things such as repository configuration security. We have this system where you can write your own rules. You can effectively, very similar to Kubernetes type CRD, you can write a rule, a software supply chain rule in YAML. You can push it to recall, and then it can make sure that hundreds and hundreds of repositories that you might have conform with the policy that's in that rule. So if I give you an example, one of them is GitHub Actions. If you look at a GitHub action, typically the version will sometimes be fixed to a tag. So you'll see the name of the action, okay, and then an ampersand and v1, v2. Okay, and that's something that GitHub advise you don't do, because you can in fact tag it to a SHA, which corresponds to a commit. Okay, so you're actually fixing it to a moment in time using the Git machine. Okay, the problem with a tag is somebody could change the code and apply the same tag again. So you might have an action, it's taken over by a hostile maintainer. They put something nasty in there to pull out your GitHub secrets and post them to a server, and they just repurpose the code with the same tag, and then you will run that. And it can perform various attacks. So it's a lot safer to fix to a digest. So one of the things that we can do with Minder is you could have hundreds of these actions, and we will automatically flip the tags to digests. And if somebody should change it back again to a tag, we will again flip it to a digest. And this is really useful because there's somebody, Fabian, I think it's Fabian Kennel, he recently did some research where he looked at GitHub Actions, and only 2% of them out of the thousands out there were using tags. So many of them are prone to this attack. But we do lots of things. We can do things like provision Dependabot or make sure Dependabot is configured to a certain value. We can make sure that branch protections are in place. We can make sure that your artifacts that are signed by SigStore are verified, and you've got that verification around the source of origin. So this is an open source platform that we're working on. It's early days. We are predominantly working with GitHub repositories, but we will be branching out to support other ecosystems over time. And this is, part of something that I wanted to get underway for quite a while. Really, is to have an open source community centric project to address supply chain security.
Let me give you an example that's probably a variation of the NPM scenario that you just went through. Let's say I am not a malicious developer, but I am bringing on what I consider to be a new package. I'm writing the new log4j, whatever that is. And I'm being as straightforward. There's a little bit of a community. It's me and a couple other people working on it, but that's it. I do my commit. It ends up in whatever registry it is. Doesn't matter. You see it, but you see that, there's not enough data here. How would you reach out to me to say, hey, look, we're Stacklok or whoever you're saying that you are. How do I verify that you are who you say you are? And then how do I come back and say, oh, yeah, okay, I'll make those changes that you're recommending?
So we're starting to roll out tooling to leverage this signal heuristics data science magic system that I told you we're building. With the tooling that we provide, developers will be able to get that information directly within their IDE. So we have a VS Code extension that we're going to release soon. We just need to get the coverage up for different languages. We've been playing around with things such as a browser extension, where if you're on a PyPy or an NPM page and you look at a package, you'll see the scores directly there. You'll get these signals directly to yourself around the risk of this. And we also have, within Minder, we have a part of a policy system where when somebody makes a pull request, if it contains a package which is questionable somehow, it has an element of risk to that, then Minder will actually step into the review, make a comment, and then outline this package that you've pushed to the repository has these certain suspicious patterns. Okay, and we'll recommend some alternatives. But what we're really trying to do is get far left as we can as possible, so that when people make those choices around what sort of package to use, we can inform them before they start to write the code and make all the efforts to build code around that particular dependency. And likewise, if you upgrade a dependency, sometimes you have like Dependabot, which will upgrade dependency. So we're also able to tell you if you introduce a vulnerability. So it might not be a malicious package, it might be a package which introduces, like you say, log4j. And we have a system where we'll actually offer to upgrade it for you as well to the most recent version. So what a lot of CVE GitLab-centric tools will do is they'll make a pull request afterwards to fix it. But we'll actually intercept it within the pull request. And then if there is a newer version available which doesn't have the CVE, we'll actually frame the suggestion which you can accept to patch directly within your own pull request to get the upgrade path so that you don't have that CVE within your code anymore.
So Stacklok can be found at stacklok.com. That's stacklok.com. sigstore.dev. And all of Luke's contact information will be down in the episode description. Luke, thanks for being with us today.
Wonderful. I really enjoyed it. Thank you.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.